Today we are going to talk about air humidification in regards to gas heat. When we are in HVAC, the main purpose of our job is to maintain and adjust the air quality within a space. Okay, that's whether we are heating the space, we are cooling the space. Air quality is very, very important. With poor air quality in a home or in a place of business, we can actually create problems for people. So we need to make sure that we are moving the proper amount of air across and through the space, and we need to make sure that we are maintaining air quality standards to promote healthy breathing and a healthy lifestyle for the individuals within the space. So the quality of air movement in an environment is very, very important in the HVAC industry. If the air happens to become too dry, that environment can become a health hazard. Okay, we have to take into effect people with health issues. If that air becomes too moist or too humid, then we can run into the situation of actually producing mold. Okay, mold can grow on duct insulation inside a furnace. It can grow on sheetrock. It can grow on ceilings. Anywhere that we have an accumulation of moisture over time, we will and can develop this potential problem. With the development of mold in an HVAC system, we run into a situation of where we can have what is called a sick building syndrome. And that is basically caused by the mold spores being transmitted through the ductwork into the conditioned space and then into the people who are breathing in that air, and can ultimately cause major health issues to some people who may be in that particular area. So mold is a plant and a member of the fungi family. Okay, and it is a catalyst responsible for the breakdown of organic matter. However, unlike most plants, mold produces spores instead of seeds. It is those spores that will become airborne, and when inhaled can produce a very bad health effect on many people. So there is roughly more than about 100,000 species of mold found in a variety of different materials. However, in the HVAC industry, it's a thing that we really do not want to have to deal with. So in terms of trying to prevent mold in a home or in a place of business, we need to concentrate on the relative humidity of the space. In the fall and winter months, homes are dry because cold air from the outside tries to enter the home. And this air is artificially dried out when the heating is turned on. Now, thinking about the characteristics of air, when we heat up air, the air expands, it rises. So when it rises, we are actually drying the air out. We are removing humidity from the air in the space, which will cause, if we do not have the proper relative humidity in the space, static electricity. You know, you go and touch a doorknob and you get shocked. You go touch a light switch, you get shocked. You'll have dry nose. You know, maybe some people who are really, really sensitive to that dry nose maybe have a constant bloody noses. That's just simply due to the fact is that there is no moisture in the air, or not enough moisture in the air to help overcome those type of characteristics. The amount of air that is in, the moisture that is in the air, we consider that relative humidity. Okay? We want to have at least some moisture in the air. Okay, relative humidity is the percentage of moisture in the air in comparison with the capacity of the air to hold the moisture. Now that sounds like a lot and can sound a little bit confusing, but basically what we're talking about, if relative humidity is 50%, each cubic foot of air is holding half the moisture that it is capable of holding. Now, to put that into a better perspective, let's think about a rainy day. When it is raining outside, the air quality is at 100% relative humidity. When we are at 100% relative humidity, the air can no longer hold the moisture content. So therefore, it's going to rain. So when we are at 50% relative humidity, the air content is only absorbing and holding 50% of what it's actually capable of holding. The relative humidity of the air decreases as the temperature of the air increases, because the hotter the air, the more humidity it can hold. Remember, the air is actually expanding. The farther apart it goes, the more it's able to hold. Your dry, warm air draws moisture from everything in the conditioned space, including your carpets, your furniture, your woodwork, your plants, and people. Everything dries out when we are heating the air in a space. Static electricity is one telltale sign that you do not have enough moisture in the air. Okay? And to prevent this, the air needs to have its moisture replenished. So we got to have a way to add the moisture that is now being absorbed and dry it out from the heating process. Now, it is recommended in HVAC to have a relative humidity in a home of somewhere between 40 and 60%. Reason why we have it anywhere between 40 and 60% is because the studies have shown that bacteria, viruses, fungi, mold, and all that other stuff, when it's in between those ranges, is better controlled. Does it 100% eliminate the possibility of it? No. But between those ranges, we are able to control and better have a better handle on the moisture content within the space. Now, years ago, in order to humidify a home, people used pans of water on top of radiators and stoves. And they even boiled the water on the stove. And when we boiled the water on the stove, the water vapor that was coming off of those pots and pans and stuff like that would travel throughout the space and would replenish the moisture content. Now, one of the disadvantages to that was we didn't have a way to control it. So as long as that water was boiling on the stove, we would continue to dump more and more moisture into the air. And eventually maybe the space would become saturated and would cause health issues. Okay, so the steam from the water would boil and evaporate into the air, raising that relative humidity in the air. And then obviously since that time we've had much better technology, and now we actually have stuff that we could put in to a piece of equipment to control this without having to constantly put on a pot of water to humidify a space. So we have what we call humidifiers now. Okay, humidifiers produce moisture, and make it available to the air by evaporation. The evaporation process is accelerated by using power or heat, or by bypassing air over a large area of water. The area of the water can be increased by spreading it to over a pad or by simply atomizing the water. And here's an example of your types of humidifier. Here we actually have a evaporative humidifier. Evaporative humidifiers work on the principle of simply providing moisture on a surface called a media and exposing that to the dry air. And this is normally done by forcing the air through or around the media and picking up the moisture from the media as a vapor or a gas. Your bypass humidifiers, on the other hand, they rely on the pressure difference between your supply duct and your return duct. Okay, when in terms of thinking about your supply and return, you need to think about the fan. Our return duct is creating a negative pressure. We are sucking the air back down to the furnace so that we can now recirculate it through the heat exchanger and back out the supply duct. The supply duct is actually in a positive pressure because the blow is now forcing and moving the air at a greater velocity. So by installing that bypass, we are using that different pressure difference between those two ducts to bring moisture into the space. Okay, these types of humidifiers can be mounted either on the supply or on the return. When it comes to humidifier location, it is recommended to follow the manufacturer's recommendation of where to locate in the best place to put your humidifier. Okay, there are many different people out there and different mechanics who will tell you different things, but the best way and the best place to install that humidifier is by following those manufacturer's recommendations. This is an example of that bypass humidifier. We have to install the humidifier. In this case, you can actually see it. It's on the supply duct right here. It's on your supply duct. And in order for this to work properly, we actually have to connect a piece of round duct and connect it to the return duct. So what's happening is as some of the air is getting returned to the furnace, some of it is going to continue down past the air filter and then through the blower and then back out, but some of that air will also now get sucked into the humidifier, where it's now going to pick up some of that moisture and some of that water, and then it will get shot back out into the space. Okay, so some of the air does not necessarily get filtered. We are taking some of that air and then replenishing the moisture content that was now removed through the heating process. Okay, then you have your plenum mount humidifier. This guy right here. Your plenum mount humidifier is mounted in the supply plenum or again in the return plenum, and the furnace forces the air through the media where the air is now picks up that moisture content. So this guy here is actually going to sit literally inside the ductwork. Okay, and I'm just going to kind of draw a makeshift piece of ductwork here. Okay, here's my ductwork. And as the air passes over it, maybe from the bottom to the top, as the air passes over these media filters, we are now going to start picking up all that moisture that's sitting on there. These pads are actually going to be wet. So as it picks up that moisture, it now will send it back out through the supply duct into the space. Your under the duct type humidifiers, these are mounted on the underside of any supply duct so that the media expands into the airflow where the moisture is picked up and then distributed. So these types of humidifiers cannot just be put, these types of humidifiers are going to be put only on the supply duct. They cannot be put or installed on a vertical piece of ductwork. They have to be installed on a horizontal piece of ductwork. Okay, these do have some disadvantages to them, obviously, because this entire basin of where this media is actually sitting is going to be filled up with water. And as long as that water is in there, we are going to build up, and it's going to get dirty. Okay, with that dirtiness, we're going to have algae, and we can actually have issues with the humidifier over time. It could slug up, it can become massively dirty, especially if we do not have preventative maintenance on them. So humidifiers need to be maintenance on a yearly basis, if not maybe even a monthly basis, depending on how much they're being used. Yeah, your media filter has several different designs. Okay, and this picture here is the underduct humidifier, and that's using a disc screen type media. And this disc are mounted on a rotating shaft that allows them to pick up moisture from the reservoir. Now, these media filters that are in here, these things are going to get dirty. These have to be replaced on a, like I said, a yearly or even a monthly basis, depending on how much the humidifier is being used. Okay, the discs are separated to prevent electrolysis, which causes the minerals in the water to form on the media, and the wobble form from the disc mounted at an angle washes any sort of minerals off and back into the reservoir, which is why we have to maintain them. Okay, we cannot just let the water sit in there for an entire year and do absolutely nothing with it. If a humidifier is going to be shut down, say for the summer months, that reservoir needs to be drained, the disc needs to be removed and thrown out, and maybe put a brand new one in, shut the water off to it, and render it unfunctional until that homeowner or that person is ready to use them again. Okay, the minerals can be drained from the reservoir. However, the more minerals and more deposit we have, sometimes you will run into the drain line being plugged up on them. Your plate or pad medias, they form a wick that absorbs water from the reservoir, and the air stream in the ductwork causes the water to evaporate from the wick or the plate. Now you have your more common and more modern, I suppose to say, your types of humidifiers, and these are your electric furnace or heat pump installation type humidifiers. And the temperature of the air in the duct is not as high as they would be on any other your typical hot air furnaces, but the electrically heated humidifiers heat the water with an electric element, causing it to evaporate and can be carried into the conditioned space. So this type of humidifier really doesn't have a pad or some sort of wheel in it. These actually have a heater in there, and as that water is heated up, it now vaporizes into like a fine mist. And it is that fine mist that gets carried into the supply ducts or into the ductwork, which will now be carried throughout the space to actually add humidity to the space. Okay, another type of humidifier is your infrared humidifier. And these humidifiers are mounted into ductwork and use infrared lamps with reflectors to reflect the infrared energy onto the water. And then that water will evaporate rapidly in the duct's airstream and is carried throughout the conditioned space. One way we need to control all of our humidifiers is we need to install what we call a humidistat. Yes, that's correct, humidistat. Not a thermostat, humidistat. Humidifiers have to be controlled by some sort of switch that is able to measure the relative humidity in the space. And those are called a humidistat. Okay, humidistats controls the motor or the heating element in the humidifier. Humidistats may be included in a digital thermostat. Some of them, depending on how expensive you want to be, can have a humidistat installed already on a thermostat, or can be a DDC type of system. Okay, your atomizing humidifiers, they're going to discharge tiny droplets into the air, which evaporates rapidly into the duct airstream or directly into your conditioned space. And these humidifiers can be spray nozzle or some sort of centrifugal type. So we have many different forms and many different ways to introduce moisture into a space. But one thing that every single one of our humidifiers have that we have discussed so far is that they all are controlled by some sort of humidistat. Okay, atomizing humidifiers should not be used with hard water because it contains minerals that leave the water vapor as dust or other distributed throughout the house. Okay, atomizing humidifiers should operate only when the furnace is operating, or moisture will accumulate and cause corrosion and mildew. Okay, so I'm going to say that again. Humidifiers should only operate when the furnace is operating, so which means when our thermostat calls for heat, we are also going to send the signal to the humidifier as well. We do not want humidifiers to run all the time. They need to operate only when the thermostat is calling for heat. The spray nozzle humidifier sprays water through a metered bore of a nozzle into the airstream, which distributes to the occupied space. The centrifugal humidifier uses an impeller or a sling to throw the water and break it into particles that are evaporated into the airstream. Your pneumatic type humidifiers, atomizing systems, use air pressure to break up the water into a mist of tiny droplets and then disperse them. Okay, so there's a lot of different ways of doing this. So sizing a humidifier is another topic that needs to be addressed. We cannot just take a humidifier from off the shelf and just put it into a piece of equipment, because if we oversize that humidifier, we are now going to overcompensate for the amount of moisture that was absorbed by the heating process. If we are undersizing it, then obviously we're not going to be putting in enough humidity into the space. So in order to do this, we have to know a couple of things. So first we need to know the number of cubic feet of space that's going to be humidified. And this is determined simply by multiplying the number of heated square feet of the house by the ceiling height. So at a 1,500 square foot house, with 8-foot ceilings has roughly about 12,000 cubic feet of space that needs to be humidified. Okay, the construction of the home is also important. We kind of need to know what it's made of, what type of insulation is in the walls, how tight the building is, the types of windows. Are they single pane? Are they double pane? And in fact, it's really kind of good to know the building orientation. Which way is the building facing? North, south, east, west? The reason why that is because we need to know what part of the home is actually going to be receiving like the brunt of the wind and the coldest part during the winter months. The amount of air changes per hour and the approximate lowest outdoor air temperature that the home is going to be, susceptible to. Now, in regards to design, especially like in Connecticut, I do believe that a lot of our heating systems are designed for 0 degrees. The coldest day of the year, we kind of figure it to be 0 degrees. Now, different states may have different guidelines or different standards for sizing certain, but based off Connecticut, because that's basically my part of the forest, from what I can remember and from what I can recall, heating systems are usually designed for 0 degrees. Okay, and obviously that last part of all of this, we need to know the level of relative humidity that's going to be desired. Okay, now remember, we pretty much set a standard for 40 to 60%. Now, rule of thumb on a lot of homes that you may run into, it's pretty safe to say that you can have 50% relative humidity. That's pretty much a really good, safe range to have your humidistat set for. Okay, if we are running into problems with humidifiers that are not working or what have you, or we're doing a maintenance on these things, we got to look at a couple of things. We got to look at a couple of issues. Okay, a lot of our humidifiers, you are going to have a humidistat. That humidistat is going to be wired to a solenoid and probably the motor on the humidifier. So once the humidistat calls and closes, we're going to need to energize the solenoid so that we can open up the water line that's connected to your humidifier, and it's also going to turn on the motor inside there, if there is one, before anything can happen. Okay? It's going to usually be an electrical issue if the humidifier is not running. Okay, so we have to make sure that our components are not seized up. Okay, we have to make sure that the wires that are connected to it are actually connected. We need to verify that we actually have power going to our components. Okay, we need to also make sure that there is not a lot of mineral buildup inside a humidifier. Okay, a locked condition like a motor seizing or a solenoid valve not delivering water to the humidifier itself can all be caused from mineral deposits. Remember, a lot of your humidifiers should not be hooked up to hard water that has a lot of calcium and mineral buildup in it. Okay, if you are in a home and they have hard water, the recommendation needs to be that they need to put in a water softening system, a system that is able to remove all those minerals and stuff that's in the water before you can even install a humidifier. Because if not, you're going to be going back constantly for issues on that humidifier. Okay, you want to check the overload protection on a humidifier. You want to make sure the circuit breakers, your humidistats, any sort of voltage issues, low voltage controls, you want to make sure all that stuff is on and functioning. You need to check to whether or not the motor is burned out on a humidifier. We need to make sure that all of the components are clean and disinfected. Okay, so remember, we are doing maintenances on services. We have to make sure that these things are clean. Excessive dust is caused by the humidifier. There is mineral buildup in the media. All of those things can clog up a humidifier sprayers and break the components in there. Okay, we have to always clean and replace the media on a humidifier. Okay, if excessive dust occurs in an atomizing humidifier, the wrong equipment has been installed. Water overflow. The water overflow indicates a defective float valve inside there. When you walk up to a humidifier and you start seeing water dripping all over the place, probably you might have a float valve in there. That's no good, okay? Because remember, we have a reservoir. That reservoir is going to fill up with water. We got to have something in there that's going to shut the water flow off so that we don't constantly dump water and spill it all over the place. Okay? Ways to kind of get around that. We can take it out, clean it, adjust it if we have to. Some float valves are adjustable. And if that doesn't work, we simply replace it. Okay? Moisture in or around the duct. Okay, moisture in the duct is found only in atomizing humidifiers. Check the control to see if it operates at other times, such as during the cooling mode or if the fan on mode is on. Okay, sometimes it could simply just be miswired. Okay, a restricted airflow may also be causing a problem. Do they have the dampers in the ductwork closed? So you might want to look at that. Low or high humidity levels. Okay, if the humidity level is too high or too low, check the calibration of the humidistat by using a psychrometer. Okay, compare what you're reading on your psychrometer compared to what the humidistat is reading. If they are not the same, then obviously we know that the humidistat is not calibrated properly, and therefore you're going to have issues with humidity levels. Okay, if it is out of calibration, some of them you can adjust. Some of them you're just going to have to simply replace. Okay, and ensure that the humidifier is clean and operating properly.